Let's attack this step by step. Beautiful question, they said. What is the coefficient of this giant thing here? To start with, it's a yz plus xy. You can extract a y into z plus x whole power 6 into 1 minus z by x whole power 6. So this is y power 6 into z plus x the whole power 6 into x minus z the whole power 6 by x power 6. I'm simplifying this as x minus z by z. So x plus z into x minus z, this is y power 6 into x square minus z square whole power 6 by x power 6. In this expansion, every term we can think of it as a combination of x square, x and z with a y power 6 hanging in there. And so we want to find coefficient of x square, y power 6, z power 4. That means we need to effectively find coefficient of x square, z power 4 in this. The y power 6 is going to sit in every term. Again, forget that. There's an x power 6 in the denominator, or we can say in this expansion x square minus z square whole power 6. We need to find x power 8 z power 4. So that this x power 6 gets cancelled and I get x square z power 4. Nicely done. Lovely. So x square minus z square whole power 6. To start with, the coefficients are going to be 6c1, 6c0, 6c1, 6c2, 6c3, 6c4, 6c5, 6c6. Typical binomial expansion. There's an x power 8 and a z power 4. So this x square whole power 4 has to be there. Z square has to be there. Depending on which way you write it, you're either looking at 6c4 or 6c2. And so we have to come back to that binomial formula. Tn plus 1, Tr plus 1 equals NCR and x power a minus r, a power x minus n minus r x power r. That expansion. But we can be super smart about it and say, look, first of all, I'm going to carve out the y power 6, keep it aside. That doesn't bother us. Then take the x power 6 in the denominator, push that aside and say, instead of looking at coefficient of x square z power 4 in this, I'm looking at x power 8 z power 4 in this. I can even say I can think of x square as k and z square as m. I'm looking at k minus m whole power 6. Within that, I'm looking for coefficient of k power 4 m square. And then simplify. Basically, this thing power 4, this thing power 2. That's what's going to happen for us. First of all, just once you square this and power 4 this, it's going to be positive. And we're looking at 6c4 or 6c2, depending on which way you look at it. Both are equal. We're looking at 6c4 as the answer, which is nothing but 6c2, 6 into 5 by 1 into 2, 3 into 5, 15. Beautiful question, because it's not easy, but it's not half as challenging as it appears at first sight. It looks like there are 3 variables, but they're not. There are only 2. Y power 6 disappears. It looks like I'm dealing with 2 expressions. Y plus one with x and z and another with x and z. Turns out we are not, because they combine to have an x square minus z square. It looks like I have something in the denominator as well. Turns out that is not, because the x power 6 can be handled away. So I'm effectively, this question is find coefficient of x power 8 z power 4 in x square minus z square whole power 6. That's it. But this is like a wrapper around it to make it look intimidating. So if we hang in there and simplify, then a simpler variant is easier to solve.